This meeting is being recorded. If you could please say yes. Thank you very much. All right, so we got a hypothesis test. We're going to apply the central limit theorem. So we're going to use some of the notes I had earlier. To do a hypothesis test, we need the hypotheses and we need some sample data. Once we have that, we're pretty much good to go. And it looks like we have hypotheses and sample data. We want the test statistic, the p-value, and then we have to make a decision. We have a little screenshot. And the screenshot, I want to get to new page. There we go. All right, so here's what we need. Leia. And add to current, yes. So this problem has a side note that I haven't talked about in class, and the book doesn't talk about it either, an idea called the binomial distribution, and we don't really need to worry about that. The bottom line is we can use a normal distribution here because we meet the requirements. And the requirements were in the fine print in the book. The requirements to use the normal distribution for a proportion is that n times p, the number of successes, has to be greater than or equal to 10, and n times 1 minus p, the number of failures, that also has to be greater than or equal to 10. And I have 282 successes out of 677. And so the reverse of that, if you think about 282 out of 67, that's going to be over 300. Both of those numbers are over 10. So I'm good there. And then I'm not too worried about that condition. If you run into a situation like that in the future, you're probably going to know a lot more stats than you do now. So what do I have here? I have my p, so this is my null hypothesis data value right here. So that's going to be important. And then I have my sample data. So my sample data gives me the sample size, and this is what I call x, the number of successes. And my sample statistic, p hat, is always x over n. So some problems, they give you p hat and n, other problems give you x and n, and you got to figure out what to do with it based on this relationship right here. So this is important. Probably should have put that in the cheat sheet. Next one, put that in. So 282 out of 677. And a spreadsheet's probably a good way to do this because then we can avoid any in-between rounding because the spreadsheet will give us a ton of decimal places whether we see them or not. So the next step here is to find the test statistic. So this right here, remember, that's what we call the sample statistic. And based on the sample statistic and the null value, we can calculate the test statistic. So that would be my p hat minus p over the standard error. And let's see, I got a chat here. Yeah, so if you do have problems with the homework, like you think you did it right, but you're getting credit for part of it, but not other parts, hit that message instructor button. So that way I can see what you entered and maybe you could tell me a little note about what you tried and I can get back to you and help you troubleshoot how to get it completely right. In the homework, you want to keep redoing it till it's right. So I'm going to do this on a spreadsheet, but I'm just going to write it down. My p hat, I'm just going to write as a fraction for now, 282 over 677. Minus the null value, which is 0.44, divided by the standard error. And to get the standard error, reminder, that is the p hat times 1 minus p hat over n, all inside the square root. So I'm just going to write standard error right there and go to the calculator to do this. So I'll share the calculator I'm using, which is a spreadsheet. So this is the same spreadsheet from last time. And go share, copy. All right, so if you check out the chat, if you don't already have this somewhere in your Google Drive, here it is again. And there's a lot of tabs here. So let's see, what are we doing here? We have a proportion. And we're doing a hypothesis test. Okay, so we want to find one of the sheets that says hypothesis test for proportion, and then we're going to make a copy of it. So hypothesis test proportion, here's one. Okay, that was the household cat one. So I'm just going to make a copy of this one, duplicate, and just enter my information in here. And it has the standard error formula. So if I go over to that for a second, it's going to take B2. So that would be the, oh, I lied, my gosh, the null hypothesis value times 1 minus that null hypothesis proportion divided by the sample size. Okay, I wrote an error in my notes. Yeah. That's the standard error I wrote here for a confidence interval. We are doing a hypothesis test. So the hat, don't go there. All right. We just have to type in our stuff. This is not birds anymore. This is some other proportion. Named. And our null was 0.44, and I have this set to automatically copy that for the alternative. And then I have the not equal to symbol there that you can always paste in if it's not there. What is our test here? Go back here and get that. We want to, oh, it is not equal right there. Okay. Yeah, so I can stick with the not equal as opposed to less than or greater than. Then p hats here, I just typed it in. So I'm going to modify this one a little bit. I'm going to insert a row, put a place here for x. X was 282 out of 677. I got that right. 282, 677.
Your alpha is different as well. It's
Alpha is
0.002 instead of.
Ah, thank you. 0.002. Yeah. Good eyes. And on this spreadsheet, I actually don't use alpha. I just have to look to see if my p-value is going to be different. For p hat here, I'm just going to go equals the x value I just typed in divided by n to get that proportion as a decimal. And here I have the p hat symbol instead of writing the word p hat, if you like. I'm going to do that, make it prettier. Okay. So we've got about 42% versus 44%. So it's a little less than 44%, but is it a lot less? So alpha was given to us right at the top of the page here. And so generally as alpha is going to be given. If it's not, we usually go for the 5% significance level unless we have a good reason to do otherwise, like maybe life and death. All right, so let's double check we got some things right here. We've got our p hat, which is calculated based on x, the number of successes, and n, the sample size. The standard error here should be the square root of p times 1 minus p over n. Okay, so I got the right formula in there. The z-score should take my sample proportion, the 0.416, subtract the null value, 0.44, that's got to be in parentheses on a spreadsheet, and then divide by the standard error, which is above here. So there's the standard error it's dividing by. Okay, then we have to decide which one do we want, and I typed the formulas in here already for you. Do we want a left tail, right tail, or two-tail? And in this situation, we were given that it should be a two-tail test. Oops, button, that one. So in this case, our p-value is about a little over 20%. That's a huge p-value. What that means is the sample data is very similar to what the null hypothesis said it should be, that 41.7% isn't much different than 44% for a sample of this size. They're about the same, is what we would conclude here. So I'm going to highlight that number right there because it's a two-tail, pink. And since that p-value is so high, we would fail to reject. name down here. This is homework 12, 8. All right, so if I go back here, and again, if some of these are marked wrong and you're not sure why, you think your work's right, send me a little message and I'll look into it. So my test statistic, according to my spreadsheet, that's my z-score. And they wanted, what, 3 places? So that 5 is going to round that 9 up. So that's going to be negative 1.230. Yep. And the computer's really not going to notice that 0, but I'm going to type it anyway for fun. The p-value for this two-tailed test, that was the 0.21887. How many decimal places? 4. 0.21887. That 7 rounds that 8 up to a 9. Okay, and that is a huge p-value. So it is greater than alpha by a huge amount. And so we fail to reject, and then we have to come up with a conclusion. Let's see. So we are failing to reject the null hypothesis. So there's not sufficient evidence that the proportion is different than 0.44. We can't support the alternative. So we got to pick the one that does that. So there is sufficient evidence to warrant rejection of the claim that the population proportion is not. Sufficient evidence to reject the alternative. That doesn't sound right. There is not sufficient evidence to warrant rejection of the claim that the population proportion is not equal to 0.44. Let's see. There is not sufficient evidence to reject the alternative. That's weird. The sample data.
Double negatives in some of these. That's
I know, yeah. I always have to puzzle through them. I didn't write this one. Sorry, someone else wrote this one. The sample data support the claim that the population proportion is not equal to 0.44. So that would be saying the sample data supports the alternative. No, that's not true. I need to check that. There is not sufficient sample evidence to support the claim that the population proportion is not equal to 0.44. There's not sufficient evidence to support the alternative. That is true. I think it's this one. Yeah, I think that's the right one right there. Those double negatives are blowing my mind there. How'd I do? Woo! I did okay today. And if you get it right, it shows you what the right answer should have been. And sometimes there's some wiggle room in certain answers. All right, let's try another one. Oh, yes, Tammy, we could put that in there. So Tammy, thank you. Yeah, sometimes I put that in spreadsheets, sometimes I don't. You can put an if-then statement in a spreadsheet that looks at like the p-value and the significance level and makes the decision for you. I have mixed feelings about that, but I'm going to come down here and put it in anyway. So let's see. Decision. Oh, you can't copy. Something changed in Zoom. You can't copy from the chat. So let's just type this out for fun. So as a human, to make the decision here, what I do is I look at my p-value and I say, is that bigger or smaller than alpha? Right? If it's smaller, I say, hey, let's reject the null. If it's bigger, I say, no, let's not. And the computer can do that decision with an if statement. So let's put it in here for fun. So if my p-value, and the problem is which p-value do I use, right? That depends on the test. So that's a whole nother issue. Could we write an if statement to pick the right one here? The answer is yes, but I'm not going to get into that here. Knowing that this is a two-tail, I can say if that p-value is less than alpha over here, then comma, I can have the computer spit out the phrase reject null. Otherwise, if that wasn't true, I can have it spit out the phrase fail to reject. And again, that decision if statement is useful. In this case, if we know it's a two-tail test. Otherwise, we'd have to go in there and change it to which other test it was. And then could you write some kind of if statement that picks the test for you based on something you do up here? The answer is yes, but it's more trouble than it's worth, in my opinion. But I do often write spreadsheets that have things like that will automatically flag stuff for me based on something else that happened, which is kind of cool. Thank you for that. That made my day. All right, let's do another problem.